Hello everyone, I hope you're staying warm. It's extremely cold out there. I wanted to take this time to just go over this worksheet with you. This was your homework for today. And I just want to make sure that everybody's on board with what we're doing up to this point. So please watch this video. This is going to be short, okay? Okay, so this is just like what we would be doing in class right now if I was with you guys. I'd be going over this worksheet with you. For one, you should recognize this illustration as a filtration, okay? And what you need to know about filtration is this is actually a separation by size, okay? The stuff that gets caught in the filter paper is too large to go through the paper. And that's really what we discussed in class, in the lab. The stuff that's going through the filter paper are things that are small enough to go through the filter paper. What are those things? Well, water molecules is one thing. The other thing is particles of the salt that were dissolved in the water. So those are basically atoms of that salt that are going through the filter paper. All right, what about this apparatus here? This is a distillation unit. When do we use distillation units? We use them when we're separating substances by their boiling point, okay? In the lab, you guys saw this at work, and what you were seeing when you watched this in the lab is you saw that this water in here was boiling, okay? And when you know by now that liquid water, when it boils, forms gas water. Water that's a gas, in other words, steam, okay? So liquid water is becoming steam, which then flows through this apparatus, and when it comes through here, it's going through a compartment that's cold, okay? So the steam is condensing back to liquid water, and then what was coming out, you can see these are drops right here. Those would be drops of pure water that are coming out of the distillation unit. The stuff that is staying behind is stuff that has a boiling point that is higher than water, okay? So again, you need to know that we use distillation units to separate substances that have different boiling points, all right? And since the water has a lower boiling point than the stuff that's in the flask, the water boils off first, leaving behind the stuff that has a high boiling point, okay? So separating by size in filtration, separating by boiling point for distillation. You need to know that. All right, what about this question number 2? Explain why the technique at the left would not be effective in separating a mixture of salt and sugar. Okay, well, all right. I know that in class I said, let's substitute the word sugar for water, okay? Now I'm looking at this and I'm thinking, well, maybe what they meant in this question was if you were to dissolve salt and sugar in water, they would both dissolve in water, right? If you were to pass that salt water and sugar water solution through the filter paper, both the salt and the sugar would go right through the filter paper, okay? So that's the answer to that question. All right, what about this particle drawing? What I did here is I drew a particle diagram of a mixture of iron and sulfur. And what I want you to get here is that I could have combined, any number of sulfur particles with iron particles. I mean, no matter how many sulfur particles in here I still have a mixture of sulfur and iron, okay? And each of those particles, the sulfur particles and the iron particles, really don't care about each other. You know, they're just in this mixture. They're just sitting there. They're not doing anything. However, when we make a compound of iron and sulfur, we found that we make a new substance. So we talked about this in class. We're making a new substance by combining the iron particles and the sulfur particles. So now you can see I don't have a mixture of sulfur and iron anymore. I have a compound of sulfur and iron. And I could have drawn as many of these compounds as I wanted to, okay? And it wouldn't matter how many of these I drew. I would have exactly the same number of iron particles as I would sulfur particles, okay? So bottom line, this is a mixture of iron and sulfur. They're just unattached. Their iron atoms don't care about the sulfur atoms, and I can mix them in any combination that I want. But when I make a compound of those two things, I have specific numbers of atoms and sulfur, of atoms of iron and sulfur coming together. All right, now as far as like this number 4 explanation for why the magnet can separate these iron and sulfur particles, but they can't, a magnet cannot separate these guys. It's because iron is on its own as an atom of iron. Iron atoms are magnetic. Okay, they are attracted to magnets. Sulfur atoms are not. Okay, but when we make a compound, we lose the properties of the individual iron atoms. The iron sulfur compound is not magnetic. And another thing that we saw is that we didn't even see properties of sulfur in the compound. The compound was no longer yellow like the sulfur atoms were yellow, okay? Or the sulfur substance was yellow. So again, I'm just going to say this one more time. When we make a compound, we lose the properties of the elements that are in that compound. All right? This compound of iron plus sulfur, iron sulfide, is not magnetic. Okay, I want to go over these diagrams with you. This was definitely your homework from last time. So I want you to check your work against what I'm showing you now, okay? And I will be checking this in when we come back. It's really important that you guys are actually learning from the e-learning that we're doing. It's expected that you're going to. All right, and if you have questions, you really need to come to class with specific questions about the homework, okay? Anyway, I'm just going to talk through this now, okay? Which of these diagrams is a mixture? Okay, A is not a mixture, all right? These are all identical particles. This particle, this molecule, is identical to this molecule, is identical to that molecule. They are all the same, so that is not a mixture. This, however, B, is a mixture, okay? We've got a mix of this molecule and that molecule and this atom. And they are all different, so we've got a mixture, okay? Here, we've got two atoms that are together. This is called a diatomic molecule. You don't have to really know that right now, but I'm just saying this particle and this particle and that particle, they are all identical, so this is not a mixture. This is a pure substance. And by the way, A is a pure substance also. All right, what about D? These are different. These guys, I want you to see that these two particles are the same, okay? But this is different, all right? So we've got this substance and this substance mixed together. That is a mixture. All right, now what about B? Which contain only compounds? Well, this is a compound. So A contains only compounds. B, okay, for B, I wrote some stuff here. All right, so this is a compound, okay? This is one atom of an element, all right? This happens to be two atoms of the same element, and they're chemically bonded together. The fancy term for that is diatomic. Remember, di means two. Maybe you don't know that already, but if you don't know that, that's what this means. Di means two, atomic means atomic. This is a two-atom element. This is a two-atom molecule, okay? All right, what about C? These are just diatomic elements. So this is only elements. And again, B contains a compound and two elements. C is just elements. They are all diatomic elements. D contains only compounds. D contains only compounds. This is a compound, and this is a compound. This is one kind of a compound. This is another kind of a compound. All right, looking at number 6 now. A is not a mixture, okay? So I want you to think about A in this way, all right? If the dots are touching each other, I want you to understand that they are chemically bonded together. Another example of that is here in A. Whoops. Here in A, all right, since this atom is touching this atom and this atom is touching that atom, I want you to think of those atoms as chemically bonded together. Again, this right here, two atoms that are chemically bonded together. They're touching each other, okay? All right, so going back to, got to get back to this, all right? These atoms are all touching each other, and they're stacked in an orderly manner, okay? I want you to think of this as a compound. It is not a mixture, okay? Okay, B, this is just a mixture. Now, I know what I just said. These guys look like they're touching each other, but when this was originally drawn, these were separated, okay? So really, we've got all these circles are separate from each other. This is just a mixture, okay? This is a mixture of two kinds of elements, as opposed to this next one here, where we've got a compound and we've got another compound, okay? This is two kinds of compounds in a mixture, okay? And then for D, this is just a stack of atoms. It's just a stack of atoms. It's just a solid of an element. Okay, so really quickly, which of these are mixtures? B is a mixture and C is a mixture. Which are only compounds? Well, A is a compound, okay? I hope that's not confusing. Please don't make that any more complicated than it is. This is a compound. It's not a mixture. All right, so what are only compounds? Well, C contains only compounds. It's a mixture of compounds. It's only compounds. And what are only elements? All right. Well, B contains a mixture of elements. We've got the dark elements and the light elements. It's just a mixture of elements. D is just a stack of elements. This would be like a solid element. You know, like each one of these dots could be an iron atom, and this would be a solid iron material, okay? Okay, so let's go through this really quickly now. let's just answer the questions here. Which are mixtures? All right. Let's see. Interesting. There are no mixtures in any of these, so none of these are mixtures. A is a pure substance. This is just a diatomic element. Okay, they're all the same, so it's not a mixture. It's a pure substance. These are all the same. I know they're touching, but pretend that they're not touching there, okay? These are all just one compound. This is not a mixture, okay? These are all just one compound. It's not a mixture. And this is just a stack of the same atoms over and over and over. That is not a mixture. Pure substance, D. Pure substance, C. Pure substance, B. Pure substance, A. Okay, which contain only compounds? A is not a compound. B is all compounds. C is all compounds. What about only elements? This is a diatomic element. All right, so this is an element, and D is just a stack of atomic elements, atoms that are only one single element. Imagine if this was all iron or if this was all aluminum. It would just be a stack of aluminum atoms or a stack of iron atoms, okay? Okay, last, which of these are gases? Well, all right, I think A is a gas. How do I know? They're separated by a lot. B, I wouldn't say is a gas. I would say it's a liquid because the molecules are pretty close together and they're not stacked in an orderly way. I would say C is an example of a gas and D is an example of a solid. All right, so gas A, liquid B, gas C, solid D. All right, that takes us through this worksheet. I hope that was helpful.